Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. The final video in the series of videos based on the important chapter of surface areas and volumes. Especially important for class 10 students for their board exams. The topic which we are going to take up is melting and recasting type of problems. If you see the CBSE syllabus, they have mentioned that there are problems which can be based on the surface area of combination of solids and the volumes of combination of solids which can be asked in the exams. This is also volumes. Melting and recasting type of problems are based on volumes. So if there is a solid which you are melting and the material obtained is being used to make another different solid, so the material is going to remain the same, right? So the volume of material of the first and the second solid, they are same, and that is why the type of question is important. So let's see the first question. How do we equate the volumes and get the unknown variable? So in this question there is a right circular cone, height, so there is a cone, I'll write cone here. The height is 8.4 centimeters and the radius of base is 2.1 centimeters. It is melted and recast into a sphere. So there is a sphere. So we are converting the cone into a sphere and we need to find the radius of the sphere. So R is to be found out. See, this will happen in all the questions. One of the dimensions will be missing and we have to find that dimension. So whenever a cone is melted and recast in the form of a sphere, the volume of cone is equal to the volume of sphere. Right, and so we can put the formulas. Volume of sphere is 4 by 3 pi r cube, so I will use capital R here, and volume of cone is 1 by 3 pi r square h. Right, so we can see some of the terms cancelling out. Pi upon 3, pi upon 3, so 4 r cube is equal to r square h, and now I can put whatever is known and find the unknown value. So 4 r cube is equal to r square h. R square 2.1 square 8.4. So 2.1 square and 8.4. Can I cancel this 4 with this and get a 2.1? So I have my direct answer. See, this becomes 2.1 cube. So the cube cancels out and we have the radius of the sphere as 2.1 centimeter. So calculation is not difficult, it is just about cancelling this 4 and getting a cube on the right hand side. So this is the first question. Let's see another one. So there is a metallic sphere of radius. So there is a sphere, I'll always write it like this. Sphere of radius capital R, say 4.2 centimeter, and it is being melted and recast into the shape of a cylinder. So we have a cylinder here. Now this is the conversion going on. The radius of the cylinder R is 6 centimeter. We need to find the height of the cylinder. So again the same thing. Volume of cylinder pi r square h will be equal to volume of sphere 4 by 3 pi r cube. So pi gets cancelled. R square, so 6 square times h is 4 by 3 r cube, which is 4.2 into 4.2 into 4.2. So I need to find the value of h from here. H will be 4 by 3 times 4.2 into 4.2 into 4.2 because it is cube, and this 6 square will go in the denominator. So I will write 6 into 6 in the denominator. So I can see so many of the factors which will get cancelled. Obviously it has to get cancelled. So h will be, so let's cancel 3, this is 1.4. Let's cancel 6, this is 0.7, 6, this is 0.7. So nothing is left in the denominator, see. So 4 times 1.4 times 0.7 times 0.7. I think you can work on it from here. This is 5.6 and this is 7 7s are 49, so 0.49. So after this you can just multiply these two and tell me what is the height in centimeters which you obtain for the cylinder. So very easy question there of melting and recasting. Let's have another question. So we need to find the number of coins 1.5 centimeter in diameter. So coins are like a thin cylinder like this, right? This is the shape of a coin. Diameter is 1.5 centimeter. This is 1.5 centimeter, and the thickness, this thickness, we need to find the number of coins of this much, 0.2 centimeter thickness, right? So let's assume this is the 0.2 centimeter. So for the coins, they are cylinders, okay? The thickness is small h, which is 0.2 centimeter, and the diameter is 1.5, so the radius is half of 1.5. So 1.5 is 3 by 2, so 3 by 4. I have reduced it to half. Now, how many of these coins are required to form a right circular cylinder? So we are forming a big cylinder, and this cylinder should have a height of 10 centimeter, and the diameter or the radius capital R is 4.5 upon 2. That is 4.5 is 9 by 2, so 9 by 4 centimeters. So he is asking us find the number of such coins required to make this cylinder. So what will we do? Whenever we have to find the number of something, number of coins in this case, we will take the volume of the bigger solid which is formed, so volume of big solid, and divide it by the volume of one small thing which we are melting. In this case it is coin. So the two volumes when divided will give you the number of coins required. Now that is the concept we need to use. Volume of cylinder pi r square h and volume of coin pi small r square h, right? So pi gets cancelled. Let's put the values. R is 9 by 4, so 9 by 4 times 9 by 4 times h. H is 10 upon small r, 3 by 4, 3 by 4, and h is 0.2. 3 by 4, 3 by 4, 0.2 is 2 by 10. So where is the problem here? I think we can cancel everything. See 4, 4, 4, 4 getting cancelled in the denominators. 3 and 3, 9 cancels out the 9, and your answer will be, I think 9 into 10 is left in the numerator, and then this 2 by 10 will go in the numerator and become 10 by 2. So this is 5. So the answer is 90 times 5, 450. So 450 coins are required to make that cylinder. Likewise, you have another question here. How many? See, again he is asking the same thing just like the previous question. Spherical lead shots. So spherical lead shots. Now you are melting these spherical lead shots, each having 4.2 centimeter diameter. So diameter is 4.2 centimeter. That means the radius is 2.1 centimeter. Right? And they are being obtained from a rectangular solid. That means a cuboid. So we are melting a cuboid and making these small lead shots. So how many lead shots are obtained? So the length is 66 centimeters. The breadth is 42 centimeters, and the height capital H, say small h, okay, 21 centimeters. Now these are the dimensions of the cuboid. So again, just like the previous thing, we have to use the same concept. Number of lead shots will be, what is the big thing you are melting? Volume of cuboid, and divide that by volume of one lead shot. One lead shot. Now this is the concept we have to use. So to obtain this, we will make the substitution of the length, breadth and height LBH, and lead shot is spherical, so 4 by 3 pi r cube, and now you just need to put the values. LBH 66, 42, 21, 42, 21, and in the denominator 4 by 3, 22 by 7, and r cube, r is 2.1, so 21 by 10, 21 by 10 and 21 by 10. Now you can see again so many things will get cancelled here, that is why they are giving these calculations. They are making it easy for you. See, 7 times 3, 21, one of them gone. This 21 in the numerator cancels this 21, 21 in the numerator cancels this 42 2 times. See, so many things are getting cancelled. Another 22 cancelling this 66 3 times. So what do you have in the numerator now? 3 into 2, 6 times. These 3 tens will go in the numerator and this 4 will go in the denominator. So you will have your answer here, 6000 upon 4, 1500. So the answer for the question is 1500 small lead shots will be obtained. So these are the questions of the melting and recasting type. I hope you have understood the entire chapter, how the combination of solids is to be used to calculate the surface area, and then how to calculate the volume based on the combination of solids, and then some of the elementary questions like this based on finding the unknown dimensions in case a solid is melted and converted into some other solid. So that completes our chapter of surface area and volumes. Do practice all the questions given in the corresponding worksheets to complete and ensure that you will be able to do everything in the exam. Do share these videos with your friends and don't forget to subscribe the channel. Thanks for watching this and all the best.